So starter one for chapter 2.7, write the following as a partial fraction. So the key thing to notice is that the power of the numerator is 4 and the power of the denominator will be an x cubed. So the first thing we have to do is divide by the denominator. Well, if we're going to do that, let's expand the denominator. So we get 5x to the 4 minus 3x squared plus x minus 7 divided by, you can use a grid if you need to, x plus 1 times x minus 2 is x squared minus x minus 2. Multiply it by x, so we get x cubed minus x squared minus 2x. So doing the long division using our grid approach, we're dividing by x cubed minus x squared minus 2x. So in here we've got 5x to the 4 divided by x cubed gives us 5x minus 5x cubed minus 10x squared. So in here we've got at the moment minus 5x cubed and we don't want any x cubed, so that must be plus 5x cubed. So that gives us plus 5 minus 5x squared minus 10x. And that gives us a remainder of the following. Well, let's look at the x squareds now that we've got. We've got minus 10 and minus 5 is minus 15 and we only want minus 3. So this must be plus 12x squared, plus 12x squared. We've got minus 10x, but we want plus 1x, so this must be plus 11x. And if we look at the units, we need a remainder of minus 7. So we've now got 5x plus 5 plus 11x minus, sorry, made a mistake there, need the whole thing, plus 12x squared plus 11x minus 7, which still got to be divided by x cubed minus x squared minus 2x. So we need to take this section and do our partial fraction. So we've got let (12x squared plus 11x minus 7 over x times x plus 1 times x minus 2 be identical to a over x plus b over x plus 1 plus c over x minus 2. Multiply through by the denominator, so we get 12x squared plus 11x minus 7 is identical to, so the x's cancel when we multiply that to leave us with a over x plus 1x minus 2. On the second term, the x plus 1's will cancel to leave us with plus b lots of x times x minus 2. And on the last one, the x plus 2's will, x minus 2's will cancel, leaving c lots of x times x plus 1. Okay, so since it's an identity sign here, it's true for all values of x. So if we put in particular values of x, it's still true. And good ones are ones that make these brackets equal to 0. So the first thing we could do is just put in x equals 0. So at x equals 0, we get 0, 0 minus 7 is equal to negative 2a. 1 times negative 2 is negative 2, so you get negative 2a, so a implies a equals 7 over 2 after the cancelling of the minus signs and dividing down by 2. Okay, now find another good value. Let's take 2. So we get 12 lots of 2 squared plus 11 lots of 2 minus 7 equals this term here. When x is 2 will be 0, so that will be 0. When x is 2, that will be 0, so this is 0. So we get 2 times 3 is 6c. So tidy that up. We get 48 plus 22 minus 7 equals 6c. So that's 60. 70 minus 7 is 63 over 6 equals C, 10.5. Yeah, we could simplify that down, multiply 3 by 3, 21 over 2. Okay, now lastly, we can put x in as minus 1, because that will mean this is 0 and this is 0, which will mean we can work out b. So 12 lots of negative 1 squared plus 11 lots of negative 1 minus 7 is equal to 0a, b lots of minus 1 times minus 3, and c will be 0. So we get 3b. 12 minus 11 minus 7 is minus 6, implies b equals negative 2. So our final answer then is 5x to the 4 minus 3x squared minus 3x squared plus x minus 7. Let's just check that, plus x minus 7, divided by x, lots of x plus 1, x minus 2, is identical to 5x plus 5 with a, we got b, a was 7 over 2, so it's plus 7 over 2x minus 2, what was b? B was 1 over x plus 1 plus c, which is 21 over 2 plus 21 over 2 lots of x minus 2.